Hey guys, Assalamu alaikum. So today I'm back here with continuation of the same topic. In the last topic, we have started kinetic particle theory and we have studied the three postulates of kinetic particle theory. Afterwards, I have told you the three states of matter, solid, liquid, and gas. We have just studied solid in detail. We have drawn the diagram of the solid, and I have told you that the particles of a solid are moving. Particles of any matter are moving, bache. Okay, so we should know this thing that either it is solid, we cannot see a solid moving from one place to another place, but we should know this thing that the particles of a solid are definitely moving at their fixed positions. Okay, so that is called a solid. When we are talking about a liquid, here I'm going to start with the topic of liquid. Okay, so this is the topic which we are going to start from liquid. It is page number 5. Okay, I'm writing the pages for those students who are facing a problem regarding merging up the whole content. Okay, so this is liquid and this is our 19th June lecture. Okay, so in case of a liquid, bache, number one thing is this, that particles are moving from one place to another place. We should know this thing that there is one factor which is called as forces of attractions are inversely proportional to the kinetic energy. Okay, now what is this? Okay, one should know this thing that forces of attractions are those attractions with which particles are holding each other, particles are attaching with each other, or they are bonding with each other, you may say. Okay, and what is energy? Energy is basically an ability to do work. Basically, there are different sources of energy, different forms of energy, you may say, but one law is there as well. And what is that law? It is called as law of conservation of energy. You people will study law of conservation of energy in physics as well, but right now I am telling you law of conservation of energy. What is that energy? Energy can neither be created nor be destroyed, but energy can be transformed from one form to another form. So kinetic energy is one state of matter, one state of energy. Potential energy is another state of energy. Electrical energy, sound energy, wave energy, tidal energy. You may have lots of different forms of energy. Okay, but right now our concern is with kinetic energy. Okay, तो बच्चे kinetic energy क्या होती है? Okay, kinetic energy is basically a form of energy which is associated with the movement of the particle. If a particle is not moving, वो नहीं हिल रहा है, it is fixed at a position, it is not moving from one place to another place, what we will say? It has a zero kinetic energy. Okay, so जब उसने move करना शुरू किया, we will say it is gaining kinetic energy. So in case of a solid, as particles have higher force of attractions, kinetic energy is low. In case of a liquid, when force of attractions will be decreased, kinetic energy will be increased. So kinetic energy and force of attractions are opposite to each other. In case of gases, we can say that force of attractions are very, very low. We are not saying zero, we are saying very, very low, or we may say approximately negligible, approximately zero, we can say. They are not zero, definitely. Remember this thing, there are definite force of attractions among the particles of a gas, which we are going to discuss the force of attractions among the particles of a gases when we will study AS chemistry. But right now we are just saying that particles of a gas have approximately negligible forces of attractions. Okay, now what we will say, there are two types of the relationships which one should know. One relationship is the direct relationship and the other relationship is the indirect relationship. Indirect relationship is also called as inverse relationship. Is that okay, bache? Now I am telling you one more thing, and what is that? Direct relationship क्या होता है और indirect relationship जिसको हम inverse relationship भी कह रहे हैं, वो क्या होता है? गर्मी ज्यादा होती है, टेम्परेचर ज्यादा होता है तो गर्मी ज्यादा होती है, टेम्परेचर कम होता है तो गर्मी कम होती है, लेट्स सपोज. ठीक है, सो हमने इसमें ये कहा कि अगर एक चीज ज्यादा हो रही है तो दूसरी चीज भी ज्यादा हो रही है, अगर एक चीज कम हो रही है तो दूसरी दूसरी चीज भी कम हो रही है, दैट इज कॉल्ड एज डायरेक्ट रिलेशनशिप. बट व्हाट इज द इनवर्स रिलेशनशिप? यहाँ पर आपके सामने जो अब बोर्ड पर प्रेजेंट है, दैट इज इंडिकेटिंग एन इनवर्स रिलेशनशिप. व्हाट इज एन इनवर्स रिलेशनशिप? In case of inverse relationship, if one thing is increasing, the other will decrease. If one thing is decreasing, other will increase. They are opposite to each other. So here forces of attractions are opposite to kinetic energy. जितनी ज़्यादा forces of attractions होंगी, उतनी कम kinetic energy होगी. Okay. When we are talking about a liquid, consider the Pepsi can. Okay. But if we are talking about the can of Pepsi, we have just given the example. In case of can of Pepsi, what is there inside the can? It is Pepsi inside the can. Okay. So if we are opening that can and pouring that can into a glass, it will occupy the shape of the glass. And if we are shifting from the glass to the plate, it will occupy the shape of the plate. So from container to another container, shape of the liquid is changing. We can say this thing, that liquid is changing its shape. Is that okay? So in case of a solid, shape was fixed. In case of a liquid, shape is not fixed. Okay. Shape is changing from one container to another container. Is that clear? Now there is one more thing which you should know, is this, that in case of a liquid, shape is not fixed, but what about the volume? Volume is an area which is occupied by an object. अगर हम पेप्सी की रेगुलर कैन की बात करें, then it has a liquid amount of 330 milliliter. 330 लिखा हुआ होता है उसके ऊपर. Okay, if you have observed. वैसे तो नॉर्मली पेप्सी पीते हुए बच्चे इस चीज के ऊपर बिल्कुल भी तवज्जो देना पसंद नहीं करते कि कितना है, बस ये है कि खत्म नहीं होनी चाहिए. Okay, but right now I'm just telling you that it has 330 milliliter of Pepsi. If we are pouring it into a glass, it will be remain 330 milliliter. It is not going to increase or not going to decrease, neither increasing nor decreasing. So volume remains fixed. If you are pouring it into a glass or a jug or a beaker or a plate or etc. Beaker is a specific type of apparatus. I'm going to introduce the apparatus to you people shortly. Okay. Well, right now I am telling you that if we are talking about the properties of the liquid, we can say this thing, that shape is not fixed. And what about the volume? Volume is fixed. Okay. And what about the movement? Particles have lesser force of attraction. Sorry, Bache. So it means that particles are moving from one place to another place. They can move from one place to another place. Why they can move from one place to another place? Because force of attractions are lesser. When we are talking about the liquid, particles can move from one place to another place in straight lines. Okay, in straight lines. There is another thing which you should know, is this, that this straight line movement is called as translational movement. Translational movement is called as straight line movement. Okay, particles have spaces, they are moving, but they don't have such a big space that they can move randomly in every direction. No, this is not a possibility in case of a liquid. In case of a liquid, the possibility is this, that particles can move in straight lines. Okay, I'm writing this as well. Particles can move in straight lines. Okay, if it is asked to draw the diagram of the liquid, this is the diagram of the liquid. Can you look at here right now? Guys, one more thing which I would like to inform you is this, that bromine, symbol Br, is an element of periodic table. I will tell you what is periodic table and how we can find out where is bromine. Okay. Bromine is there in the periodic table. Guys, there is a past paper question in which examiner is asking bromine is an element of periodic table. One should know this thing already, that bromine is an element of periodic table which is in the liquid state. Okay, I will teach you the topic of periodic table. At that time you people will be more able to understand this concept, but right now as I am telling you about the liquid, I am telling you this thing very clearly. एक पास पेपर के क्वेश्चन में एग्जामिनर कहता है कि draw the diagram of bromine. This is a diagram of bromine. How it is? Because in case of bromine, the particles are not very much far apart from each other, but they are not very much tightly packed with each other. Guys, compare it with solid. You can see this thing that in case of a solid, the particles are tightly packed, whereas in case of a liquid, the particles have spaces. The particles can slide over each other, can slip over each other, can move into straight lines type of thing. Is that okay? So this is how we can talk about a liquid. Is that okay? I am taking you people to the next page, and this is now page number 6. Okay. Today we are going to discuss about gas as well. When we are talking about gas, oh, where is gas? How we can find out gas? Bache, we are right now sitting in a gas. What is that gas? This gas is air. Oh, gas, air is made up of one gas? No. Air is a mixture of gases. Mixture means these gases are not reacting with each other. These gases are not giving any chemical reaction with each other. What is air? Air has a specific composition. I am telling you very clearly right from the beginning of the course that you people should know what is the composition of air. Composition of air is 78% nitrogen, 20 to 21% oxygen, 0.03% carbon dioxide. By the way, this percentage of carbon dioxide is not mentioned in your syllabus very clearly, but this is the percentage which I have told you. If you are memorizing carbon dioxide percentage, well and good. If not, even then okay. But these two percentages, that is about nitrogen and oxygen, should be in your mind. And what is after carbon dioxide? Remaining are water vapors, neon gas, argon gas, helium gas, etc. Okay, rather all these three. Etc. is a word which can create a confusion, so you people may forget this word of etc. Keep this word in your mind, that 78% of nitrogen, 21% is oxygen, remaining are 0.03 percentage of carbon dioxide, remaining are water vapors and neon, argon and helium gases. Okay, lots of explanation related to this composition of air. Number one is this: if examiner is asking about dry air composition, over there you people will not mention water vapors. Dry air, it means that no water, no moisture is there. Number two is this, guys, if you are looking into the periodic table के अंदर elements के symbols जो है उनको mention किया गया है. I will show you the periodic table as well. In case of periodic table, let me try to show you the periodic table as well. Okay. Periodic table, might be I will be able to find out where is periodic table. Okay. No periodic table is here. OMG. Okay. I will try to tell you the. Okay, I can tell you right now, but we can definitely have a discussion about periodic table as well when I will teach you in the details of periodic table. Okay, but over here, I'm telling you that in case of gases of mixture of air, we are just telling you one thing one should know is this, that in case of air, these all gases are combined with each other. One should know this thing very clearly, that these gases are not reacting with each other. These are the combination. Air is a mixture of different gases. A gas is filled in a tire of a truck, in a tire of a bicycle, in a tire of a car. Gas is filled in a balloon, in a heart-shaped balloon, in a Dora balloon, in a ball-shaped balloon, in a regular balloon shape, in a Mickey Mouse balloon, etc., etc. And one should know this thing as well, that it is occupying the shape of the swimming pool. You people are playing in those swimming pools in the summers, and it is filled with different air pumps, and it is occupying the shape of the balloon, either rectangle or circle or triangle or etc. So it means that one can say this thing, that shape of gas is changing from one container to another container. Just like liquid, shape is not fixed. And what about the volume? Oh, yes, volume is also not fixed in case of gases. Okay. What about the volume of the gases, bache? One should know this thing, that in case of volume of gases, I am telling you very clearly, volume of gases is not fixed as well. जिस कमरे में हम इस वक्त बैठे हुए हैं, let's consider the room in which you are sitting. Either you are sitting in a car or anywhere. Just consider that area, consider that place, and consider it in a tightly packed form. If it is closely packed, all the particles are pressed, all the particles of air are compressed here. All the particles of air might be able to fit in into a matchbox. Just consider this thing. Matchbox is a small thing, a small container, whereas your room is a big container, big area. Okay, so it means that when we are compressing, when we are pressurizing, the particles are coming closer to each other. When we are releasing the pressure, particles are moving far apart from each other. So we can say this thing, that particles can be released in case of a gas. So particles can occupy the available space, all available area in case of gases. So volume is also not fixed in case of gases. Shape is not fixed, volume is not fixed as well. अगर आप उसको किसी बैलून में भरते हैं and you are popping off that balloon, all the gas particles from that balloon are are moving here and there, are trying to occupy the whole area around that balloon. In this way, it is a proof that in case of a gas, the particles are occupying the whole available area. So in case of gases, हम revise करते हैं, shape is not fixed, volume is not fixed. As we know this thing, that in case of the gases, the forces of attraction, which are holding each other, are very, very low. So when forces of attractions are very, very low, it means that kinetic energy will be very, very high. So particles are freely moving from one place to another place. Random movement of the particles will be observed. Particles are hitting each other more. Particles are hitting each other very less frequently because they have lots of space. Okay. So I'm writing point number one as this. Okay. Point number one. No fixed shape. Number two. No fixed volume. Number three. Particles are moving randomly. Rotational movement. All right, guys. And one more thing is this, that we are going to draw the diagram. Look at here. Okay. One particle, another particle, another particle, another particle, one particle. That's it. Oh my God, yes, such a huge space among the particles. Particles are hitting each other. You may say not very much frequently, like you may say they are not very much closely packed, but they can hit each other because they will be bounced back. Once one particle is hitting the other, it might hit the wall, it might hit back to that particle again. So this is happening in case of a gas. But in case of a solid, as the particles are hitting each other, or you may say they are moving at their fixed position, there are lesser chances for them to leave their places in case of a solid, and there are greater chances that whenever we are just increasing their hitting their movement by any source, let's suppose by increasing the temperature, at that time in case of a solid, the particles have more ability to hit with each other. Okay, so let's suppose this, because you should know this thing. Right now I'm taking you to the next part of this chapter, and that is associated by increase or decrease of the movement. But one should know this thing, that by increasing the temperature, kinetic energy of the particles will increase. Okay, so you should know this thing, that temperature is the degree of measurement of heat basically. So when we will increase the heat, when we will increase the temperature, kinetic energy of the particles will be increased. So guys, we are done with the solid, liquid and gases. We are done with their name of the movements. We are done with their shape and volume. The generic diagrams of the solid, liquid and gases are done as well. And now we are moving to the next page, and that is page number 7, on which we are going to write the topic interconversion of one state of matter into another state of matter. Interconversion. Let me write the topic and then I will tell you the explanation. Interconversion. Interconversion of states of matter. Okay. Guys, let's suppose, what is interconversion? Interconversion, the name is telling you how to convert one substance into another and one substance back into the other. Okay, so how we can convert one solid into a liquid, or a liquid back to solid, or a liquid into a gas, or a gas back to solid, or a solid directly into gas, so a gas directly into liquid back. So all these changes are possible, but how these changes are going to be possible? Okay, one should know this thing, that by increasing the temperature or by decreasing the temperature, temperature ज़्यादा करने से या temperature कम करने से, one state of matter can be changed into another state of matter. Guys, you should know this thing, that there are basically two types of you may say processes. One type of the process is called as heating processes, whereas other processes called as cooling processes. Okay, so I am just telling you, heating processes are those processes in which heat is added, So we can say this thing, that in case of heating processes, heat will be added, temperature will be increased, kinetic energy will be increased. In case of cooling processes, heat will be removed, temperature will be decreased, kinetic energy will be decreased. I am just writing a flow chart type of thing here. Look at here right now. I'm writing regarding kinetic energy. Guys, till now you know this thing very well, that gas has a highest kinetic energy, and after gas, what is the next? It is called as liquid, and after liquid, what is the next? It is called as solid. Okay, all right, done. All right, okay. So if you are going to increase the temperature plus heat, heat is added, solid will be changed into liquid. If you are going to increase the temperature again, and you are increasing the heat, a liquid will be changed into the gas. Okay, now I am writing with the black. Minus heat, so heat is removed, heat is subtracted, a gas will be changed into the liquid. And minus heat, a liquid will be changed into the solid. Okay, so till this level we have discussed this whole thing. Further interconversions and details will be taught to you after this. Thank you very much, guys. See you in the next class. All the best to all of you. Most welcome. For any question or a problem, you people may send me any problem or a question over there in the YouTube chat. Thank you very much, guys. Allah Hafiz.